Hello everyone. Thank you for joining the Application Manager free training series. Today we'll be focusing on how you can get started with the Java, Node.js, PHP and .NET Core applications based monitoring and finding the distributed transaction tracing in a microservice based environment, isolating the particular bottlenecks, performance related bottlenecks of your application through threat profiling feature of Application Manager APM Insight. And finally, we'll be discussing about setting up the alerts for critical performance indicators of your application and how well you can achieve that using the APM Insight solution. This is going to be the agenda for today. If you have any questions during the course of this webinar, please feel free to ask your questions in the chat panel so that you can get it answered from our expert panelist. Let's get started. So before we get into the technical aspects of the solution, let's understand the need for IT teams to have connection to the current business. When the IT monitoring teams or DevOps team or service reliability engineering teams understand the core business operations, say for an example, a particular technology stack is not configured properly due to a human error, or it is misconfigured due to a disaster setup. So that's where the teams can understand that this technology is related to this specific business unit, through which they can correlate the technology and business stack to resolve the issues quickly, thus by reducing the mean time to time repair ratio. As we all know that most of the IT teams were working remotely from different geographical locations, and the on-site teams were quite less, and most of the teams were offshore monitoring the applications either from their home or from specific locations. So maintaining connectivity to the remote site is quite challenging during this pandemic, and most of the companies have recovered and they were able to manage the remote sites using this during the pandemic. However, 88% of the application stakeholders still admit that monitoring the remote applications is quite challenging because this involves a significant amount of bandwidth, VPN bandwidth consumption, and sufficient network level privileges and security accesses required to maintain the production grade application. And managing the distributed applications from remote teams is again quite challenging, which requires continuous collaboration with the team members and educating them with the new technology stack being deployed. And a continuous amount of knowledge transfer is required in this pandemic to monitor the applications. So let's see how Applications Manager can help you to observe the full stack component deployed in your IT infrastructure completely and effortlessly, how we can make sure that your applications were performing well, and that's why you can ensure that the end user experience is always positive. As we all know that the application consists of multiple components: front-end component, back-end, database, DevOps systems, and other related components. Say, for example, let's take a look right here. So when you see that your application is slow, as we all know that this application is consisting of a backend component, database, and a front-end PHP or HTML component. When we track a specific request from a user, and user is requesting to a content, or they are trying to load an healthcare-based application to view the patient records. So they enter the user ID and password. They try to enter into the website, and then if the website or if the web server is loaded with too many sessions, or that is concurrent sessions, then the web server might not respond back properly. In that case, a load balancer is required to split the loads to multiple nodes or multiple clusters. If the load balancer is misconfigured in a different way, which is not expected, that might result application performance issue. And memory issues, which is unexpected. Say, for example, out of memory exception due to a specific large report. And again, memory leak due to a thread's high CPU or high thread usage. And one of the most important component that most of the teams needs to know about is the app code performance. Whenever we whenever we talk about the application performance, the system administrators or the DevOps team always focus on CPU or memory or the disk, which is a primarily basic components. However, one needs to know which specific code snippet has caused high CPU utilization and which specific uh, DB call is causing slowness to your DB. So, what if we understand this specific information, that would be quite helpful to maintain a gradual performance for your application. And let's see the common traditional application performance troubleshooting approach. Whenever the user get in complaint saying that the application is not performing well, these healthcare team try to raise a ticket for the specific incident, and then the incident is being analyzed and it is being forwarded to the uh, developer or the DevOps team for the next level of analysis. They try to gather the logs from the user, understand the exceptions being triggered, and then build a fix for it. All these were time consuming tasks where the end user experience will be already impacted in this specific stage. So how you can overcome this using and you would need an application performance management solution to overcome these problems of high repair ratio and the experiences of your customers were already impacted. So when it comes to the critical application performance or data center performance monitoring, the companies are always ready to make huge investment, but somehow, despite the efforts invested in the infrastructure capacity planning, many IT organizations still face or continue to deal with the downtime which is unexpected as a cause of hardware, software, and downtime incidents. So, and these downtime would last from probably for a few minutes to several days, causing tremendous loss. So, using the Manage Engine Application Manager APM Insight, you can shift to a modern approach for the application which involves high complexity or the digital applications. Say, for example, you would get the AppDex score on the GUI, average response time, throughput, error count of the mission critical applications which you are monitoring. So let me give you an example, and let's take this example throughout this webinar of using a healthcare based application. Let's take an hospital where the users were trying to access the website to get their records and download their reports, historical reports, patient reports. And whenever the user is trying to fetch the report from the website, if it takes long time, then the user would be definitely impacted. So basically, we talk about the brand revenue loss or something, but in this specific case, delivering an rich user experience is quite mandatory as it directly impacts the human life. So let's see how we can set up a proactive monitoring to ensure a flawless application performance. Let me switch back to the applications managed GUI and get into action. And let's see a live demonstration of the solution. We are in the applications manager product GUI now. So as a first step, you can download the Manage Engine Applications Manager from our website. And APM Insight is an agent-based application performance monitoring solution. And this APM Insight agent is capable of monitoring Java, .NET, Node.js, PHP, Ruby on Rails with a complete full stack visibility. In the previous slide, I have mentioned about full stack visibility, which consists of multiple components. So all these components were completely responsible for the applications to be up and running. If any of these components have any minor issue, that might definitely impact your overall application performance. So let's see how this can be identified and fixed at the initial stage itself before you get an actual complaint from the user. First up, download the APM Insight agent from the website. You can download the agent based on your application stack. If you wanted to monitor a Node.js based application, then you can very well download the Node.js agent, follow the instructions to get started. So once the Node.js application is, once you deploy the Node.js agent in your web server, the agent collects the data continuously every 1 minute, and you can view the data right here in the applications manager dashboard. And this dashboard is a single pane of dashboard for your multi-stack systems, whatsoever application you have. And this is the place where you can view the performance, which acts as a centralized dashboard. Thus, by helping the IT administrators to avoid multiple tools. Say, for example, an IT admin, and a recent study says that a single IT admin is using 3 to 4 monitoring tools to have a view on their IT infrastructure. So that's the primary problem, wherein one needs to aggregate the data from multiple tools, even though the tool is to reduce the efforts from the IT teams. But however, managing multiple tools is definitely a quite challenging part for them. So by deploying this APM Insight, say for example, let's take this Java application and let's discuss about the key performance indicators, which is directly responsible for your service level indicators of your specific application. So AppDex is nothing but application performance index. And this AppDex score is split into 3 parts: satisfied, tolerating, frustrated. So if the AppDex score is, one has to ensure the AppDex score is always high, saying that the range starts from 0 and the maximum score possible is 1, which indicates that the application is performing flawlessly. So, and AppDex score is a direct measure of your SLA, application SLA, and average response time, how much time your web application takes back to respond to the user request. Throughput, how much future request that your web application can serve for the future needs from the customer. So during this pandemic, a healthcare application will be accessed continuously from different geographies or from different uh, branch office of a specific hospital or from a specific patient. So it is quite important that the throughput of your application should be always high, and that should be always high. So when you set up the application performance monitoring, these are all the key performance indicators that one needs to definitely implement for flawless performance. Thus, by identifying this information, you can sit back and relax about your data, because it gives you an overall performance or overall picture of how well your application is performing. So we show you the application code wise component and the database component by split up in a specific transaction. How much percentage is consuming for app code and how much is for database related operations will be shown right here with its response time broken, split up. And you could always find the request throughput, data throughput, exceptions count. How exceptions nothing but unhandled exceptions. Say for example, a user is trying to get a report for the data which is not available, then the application itself will show them that the data is not available, which is handled exception. Unhandled exception is something which occurs in the code due to multiple external reasons or due to internal reasons in the code level. So let's see those detailed in an upcoming slides. For now, in this dashboard, we show the exception count and errors count, data throughput with bytes in and bytes out. And you can also find the split up of the exception. So these are all the exceptions which happens in my Java application. And you could see that unknown host exception is the specific category which is occurring very frequently. And the database related exception is occurring intermittently. So I need to analyze that why this unknown host exception is occurring. An application manager is very well capable of giving you more information with this stack trace to directly pinpoint the issue. So let's see that in the upcoming slide as well. This is, and here you could find the top 5 transactions based on the response time and its slow traces and exception traces as well, along with its exception count. So unknown host exception, how much time, that is the count of this errors, how much time the specific exception is occurring in the application, which helps the application owners to fix the issue permanently. So let me switch back to the presentation. So let's see the next topic for today, that is drill down into transaction via distributed tracing in microservice environments. So before we talk about microservice environment, let's take a real-time example of a microservice environment. So our day-to-day life revolve around these applications which we use. Say, for example, to engage with the customers, to engage to you, we use a platform to connect with you, which is a web-based application. To transact with our customers, we use an application. To connect with our friends, we definitely use an application. So these applications were part of our day-to-day life. So to you just have to ensure that we expect that these applications should always perform well. Think about the last time you have experienced a poor application performance. Either you might be tolerating, or you will just ignore and move on to a next service. This is the two different mindset that people would have. Now coming back to the microservice environment, let's take a look at the right side of this slide, which is a Java EE based application consisting of a JVM. In order to monitor a Java based application, traditionally we can use a log file to monitor the Java based application, which requires human effort. One have to get the log file, and these log files will be a multiple log files in different source. You have to analyze to find what all the exception occurring along with its stack trace, which is a time consuming process, which I have explained previously in the initial slide. The other way is setting up an rich application performance monitoring solution, which is capable of automating the analysis by itself and producing the dashboard. This is the two ways that which is happening traditionally and the modern approach for the cloud native applications. So now let's shift to the new modern era of digital applications. Most of the digital applications, considering the scalability of the application, the application owners were moving to the container-based approach, which will be quite helpful for them to scale up if the demand from the application is high. Let's take a Kubernetes cluster, and this cluster is capable of hosting multiple nodes, and each node is having a backend component like Java, Node.js, and a front-end component like PHP, and it also has a container of SQL-based container. All these were Kubernetes cluster in a cloud-based system. So all these components will be outputting the log files in a different location. It will be quite challenging for the specific monitoring teams for a cloud-based applications, cloud native based application to track what information these log files were storing and how to decide the data based upon its approach. So let's see how this could be done right here using a business observability solution. So collecting the data is one of the important aspects from all these containers or from all these nodes. Monitoring using the rich dashboard and analyzing to find the historical trend of the performance. And if there is any issue which is observed, then fix it, which is a very simple 4-step process for this complex applications, whichever is deployed. So Application performance management solution, an API-method solution, can break down your operational silos, and it can also allow you to meet and exceed your customer expectation in terms of the application performance which you have promised. That is, you can always succeed the SLA which you have committed for the customers by deploying a continuous application performance monitoring solution. Let's get started for the solution. So we have discussed about monitoring an application in a microservice-based environment in a different cluster-based systems on cloud. So distributed transaction tracing can be very well correlated with that term because your application is spread across multiple nodes in a different data center or in a different geographical locations maybe. So focusing on the execution flow is quite important because one have to understand the complete journey of the entire request across multiple applications so that you can pinpoint and track a specific service request in case of any issues. Because the application is not only involving these components, it also has an external APIs and an internal REST API calls for multiple functionality inside the application. So in order to track the application call for a specific service request, you might have to add an HTTP header containing the metadata required to track the specific request so that you can filter and pinpoint the specific request. Say, for example, an user is trying to fetch the historical information of their treatment. So this involves a large amount of data to be pulled from the database. So in order to track this request, we have to know which request this is, what's the method will be called, and what's the backend SQL query will be called based upon the user request. So that's where traditionally people add an HTTP header to track this. However, deploying an APM inside solution like Application Manager can help you to get this data out of the box in the GUI itself without much manual efforts. That sounds interesting. So let's see how we can get started with that. So you can also, this is how it looks like. You can trace the transaction trace made from one application to another. And you can also refine the business transactions for your key business metrics. So you have to identify the key business operation in your application and get the alerts for the specific business operation. So as a healthcare based application, uh, someone needs to ensure that they were able to create new forms for the patients in a digital way. And this should be always available 24/7 without any issues. And there should not be any slowness with specific to this business metric. So how we can ensure that? Let me switch back to the application manager product GUI and let's have some real-time action of this. I was talking about the business transactions monitoring and understanding the business along with the technology stack. So when we talk about the technology stack or the transactions, business transactions, we show you all the transactions listed based upon the API inside the agent configuration that is made. So by configuring the sampling factor, one can actually ensure how many number of transactions needs to be captured from your application. It's a web-based application. And you can also configure the key business transactions. Say, for example, configure key transactions is the option. And all these metrics or the transactions will be listed right here. The business owners or the application stakeholders can choose the specific transaction and can save it, based on which they can pull specific information about their key business transactions, which is a direct impact to their business. That's why you can also focus on the shared priorities, whichever is important and directly impacting the humans or your customers. So this is how you can set up those. And as we all know that the application will be definitely having a background transaction, which is might be due to a database cleanup or scheduled report pulling activities inside your application. So these background transactions will be automatically traced by this solution itself, which gives you the transaction name, which transaction is that, count, errors percentage if there is any, average response time, average CPU time, and the key transaction. If it is key, that will be marked separately. And whatsoever transactions were having issues, based on the error transactions can be filtered right here by choosing the same. You could view the high level data of your error transactions. So this is the page where you can view the business transactions along with its throughput, and AppDex score, request count for the each and individual transactions. So let me switch back to the presentation. So one of the most important aspect of the application performance monitoring is capturing the error traces, dive into slow SQL statements. Why this is important, right? In order to capture the error traces, application manager, by just choosing a traces tab, and you could find the error transactions along with its high level trace information, along with the slow method calls and count, which is directly impacting your database. The primary purpose of finding this information is to fix this. And ultimately, using this data, the developer along with the DBAs can improve your application performance. When a performance issue rises, why the performance issue rises? Might be due to a CPU usage, memory usage, right? So why the CPU usage is occurring, which is due to a high CPU consuming threads. And why this thread is consuming high CPU, that's the next question one will have. And the answer for that question is by understanding the method which that specific thread is pointing, you can find what exactly happens inside the method. When that method is called, what are all the SQL statements involved. You could get the time consuming methods along with its invocation count for every method. Thus, by you can identify the components whichever is causing CPU usage. Rather than increasing the CPU usage or increasing your RAM or increasing the cores of CPU, you can directly focus on root cause, which is actually causing the CPU, and can fix it and can improve your application performance. Let me switch back to the product GUI and show you how this could be done. So we have discussed about capturing the slow database statements. When you just choose this database tab right here, you can actually find the database operation along with its query and the errors percentage information, throughput, and the database operation by its caller value. So this would be quite helpful to have a clear split up of the method which is being involved for the specific query. So this is split up minimum, maximum, and 95th percentile value, and the database operation response time, which is the minimum, max, and 95th value, database operation throughput for this specific statement. So as we all know that whenever a method call or application call is involved, directly from the backend component and specific CRUD operation will be triggered. As a result of this CRUD operation, these are the statements which were getting executed in your database. What if there is a query which is consuming longer execution time? As a result, you might have to wait for a long time for the page to load because the database is taking long time to respond or a long time for the execution. Once the database responds back to the data, only then you can have the data visible in the GUI of your application or in your website, which is why this monitoring is quite important. Hope that's clear. Now let me show you the traces. This is quite important and most helpful for application performance debugging and continual improvement. As a first step, all the transactions whichever is exceeding the threshold value. Using the agent configuration, you can actually set up the threshold value, the response time for which the traces will be captured. Once these traces were captured, you can again filter it based on its response time. As we see that this specific transaction is causing high response time, that is show resource.do is a front-end method, and the response time is 28 minutes, which is completely unexpected for an user from a user perspective. So let's dive deep and see why this took 28 minutes to respond back to the user request. When the user clicks that page, they just wanted to view the details of their application. So that, and then they just click that page. As a result, with this involves 15 method calls plus 2231 SQL DB operations being triggered. So as a single method call is triggering 2000 plus operations to the database, DB operation. And again, this is a get method, and we could see that the response code for this transaction is 500, the HTTP response code, which is definitely causing an impact because it is not as expected, right? 500 response code is something an issue with the performance with this specific transaction. Let's see why this issue has occurred. So you could very well see the statements, slow method calls and counts detail, and this is the specific method detail, and trace details right here. Can drill down and see the complete stack for this transaction and can get the high level data out of it. And the SQL statements, which is DB operation calls, and the number of queries is 1992. So this is definitely a case that one can expect slow application performance because the operations to the database is high. So developers have to introduce caching to improve the performance right here, or they have to fine tune the query in a such a way that the request to the database operations is quite less, or they have to optimize the code also to improve this performance. And the application full stack is not only a single component of uh, backend component and a database. It involves third-party external calls to any API. Say, for example, there were few website which uses uh, a Google APIs, their map to locate their address. So in some case, if there is an latency with the third-party APIs, then someone can expect a delay in the page loading, which might again cause an direct impact to the performance, and which is not the issue of the actual applications team because they are using a third-party APIs, which is taking long time. So if someone understands that this is the API consuming long time, they can definitely see what has caused the issue and can fix that. That's the reason that you need to focus on these key performance metrics. So now we have discussed about the traces. Let me switch back to the presentation and let's see some basic information about the error traces and can get some live insight about the same. So we have discussed about the traces monitoring, and let's see some useful information on the key principles of business observability. So when we talk about the business observability, one have to understand the loss of application service or the loss of data due to a system outage will be definitely having a significant legal and financial implications. So thus by having a clear idea of the business observability, one can definitely prevent and be proactive before these issue arises. So how to set up this? So understand the business context of the application being monitored, correlating with the technology stack. Once you understand where the issues are occurring, Align teams to focus on shared priorities by configuring the key business transactions for your key workflows. That's why you can face the customer with confidence, can meet their and can exceed their expectations, thus by delivering a rich customer experience for your customers across the globe. And three primary things which you can do is building an automation like an automated performance monitoring solution, understanding the business context by relating the traces with the technology stack, building an action. So this is what an issue has occurred, and building an action like performing an automation or creating a script to reduce the repair time. That's where the users or the application team has to focus on. So in a recent survey conducted by Gartner, they actually say that the average cost of network downtime alone is around $5,600 per minute. This is a revenue impact. Apart from the revenue impact, there are other impact related to the application performance, which is brand reputation, similarly revenue impact, and for healthcare-based applications, the pressure will be quite high as it directly impacts the human life whenever they are trying to see the specific availability of hospitals or any record they are trying to fetch. The data should be available, accurate, and it should be properly responding back to the user, which is crucial, and it is treated as mission critical application. And that's why it needs a proactive monitoring. So let me switch back to the product GUI and see how you can monitor the error transaction traces using the applications manager. So this is one of the most recent error transaction which has happened in my application, and the response time is 21 seconds. And this is the specific method which has caused error because this is the URL which was trying to connect from my data center. This URL was not accessible, resulted in a connect socket exception. And let's see the details of the same. So this is the connect exception. And as this was a different URL from my application, this is treated as an external call. And the SQL statement, this error transaction doesn't involve any SQL. So you can see that as this was an external call, external HTTP call, it was listed right here under HTTP call category. And definitely we know that this was having an exception because the response code was 500. So this is the exception, and this is the exception class. Most importantly, by just choosing this view stack trace, you can actually find the high level information which helps the users to fix the issue. And you could choose the other traces of this transaction to view the same. And for Java-based applications, we all know that the Java application consists of a JVM, and heap memory will be allocated Java heap max, and will have a minimum heap memory also. So if it exceeds, if the application consumes the maximum allocated heap memory, that's where the out of memory exception occurs inside your application. So that's where you need to be proactive in terms of JVM based monitoring for your critical Java based applications, which is direct impact. And also you can have the JVM CPU usage being monitored along with its runtime memory, heap and non-heap memory, and the JVM classes count and just-in-time compiler information. And most important aspect of a Java-based application will be garbage collectors. So this garbage collector is quite important in terms of removing the unreferenced objects from the machine. So you could find the collections count right here, time spent, total collections, and the total time spent. And if it's a multi-threaded based application, you could find the threads data right here along with its aggregated CPU and user time of all the threads, minimum, maximum, average, and 94th percentile of these threads based on multiple state. So live thread is one of the state, and if there is more number of peak threads, that's where we need to be careful in terms of application performance monitoring. So similar to that, when we choose this exceptions tab right here, we could see all these exceptions listed. So let's take a look at this unknown host exception. So when we choose that specific exception right here, you could see the specific transaction being shown right here. From this unknown host exception occurs when there is a bulk request to this API has been made. So we could actually find that this API is trying to reach to this specific host in this port, and from the machine where the request is being originated, and while it reaches the destination location, it is unable to resolve the host, which might be due to an DNS server issue. It's not an application performance issue, and this issue occurs at the network side. So by analyzing this information, this is definitely having an impact to the overall application performance. Even though it's from a network layer, it impacts the application layer too. So by fixing these issues with the help of NOC team, one can actually ensure that the application performance is being improved. And the service map information right here, which is nothing but a simple architecture level information of your application. Your application is built using multiple stack, Java, database, web server, APIs, and a cloud component, container-based systems. So you could see the interrelation between these components and the current running status of these components. By just doing a mouse over, you could find the average response time and the request, failed request, and total request throughput of these specific components. You could also set up the application parameters to actually find a specific uh, information. That is nothing but application performance meters views. And for more information, you could probably refer this help link. Also reach out to us for high level information on application parameters. Our team can provide you a customized solution for the same. And previously we have discussed about thread profiling to find the specific thread which is causing high CPU usage. And this thread profiling is nothing but viewing the thread dumps. And this thread dumps can be viewed in two different ways, which is nothing but on-demand thread profiling and scheduled thread profiling. So on-demand thread profiling, you can just choose the option, specify the profiling duration right here, and then you can choose start profiling. The moment you choose the start profiling, you could find the data which looks something like this. Say for example, thread ID, current method, CPU time. So these are all the specific data from the thread dump, which would be quite helpful to find the high CPU usage components. So let me switch back to the presentation. Almost we came to the end of this training. This is the last part of this series, setting up alerts for critical performance parameters. So how you can set up the alerts for critical performance parameters? So you can get the application error based on its count. So as I have been initially explained from the product, to get these errors from multiple sources instead of waiting for the log files from different locations, the agent itself gathers the data from multiple sources and show you the data in a single dashboard. Thus by helping you to avoid multiple dashboard, multiple tools, analyzing the logs, everything can be overcome. And also get rich in business intelligence level data, that is get the historical application performance data for your application which is being monitored. Any type of custom application or application it could be, you could get the historical data for the same. And similarly, we have talked about business observability using the application manager, that is understanding the business and relating to the technology stack, and then building an automation. In order to build an automation, the tool provides you multiple out of the box ways. That is, the tool is capable of sending the alerts from any performance issues, and these alerts can be directly triggered to any webhooks. You could perform AWS or Azure based automation. As most of the application in modern digital systems were cloud native, and most of the actions needs to be in a cloud based systems only. So using this option, you can directly perform the cloud automation and getting the Slack notifications. Using a single click option, you can integrate your Slack with monitoring solution, application manager, to get all your application performance related alerts directly to your Slack notebook. And SQL job based automation for DBAs. Uh, there are multiple jobs which you can start, stop, or restart to a specific application performance related issue, which can be linked with any of the performance key performance metrics of the attributes, whichever is listed right here in the screenshot. And also you could create custom based script to perform whatever action that you wanted to. And we support shell based script. We support Windows machines. We support batch script, and we also support partial based scripting, which is highly customizable for any complex based applications. And the tool will automatically call these scripts which you are going to point, through which you can perform high level automation, and which will directly help you to reduce the mean time to time repair ratio, or for continuous uh, maintenance. You can also use the automations which is pre-built in applications manager. So I have just listed the very basic automations, and there were few more automations available in applications manager. And for high level information, you could send us an email. We can provide you a personalized demo on furthermore automation and orchestration profiles that we have. The almost we came to this end, and let's have a quick summary of what we have discussed now. So we have discussed about configuring the performance monitoring for your production grade application, tracking the application in a microservice based environment. We took an example of Kubernetes cluster based systems, and we have identified how we can use the thread profiling option to find which specific code snippet is causing performance impact to your application. And finally, we have discussed about historical application performance data to understand the overall trend of your application. And we have discussed about various type of automations for cloud native applications and for container based applications. We thank you everyone for joining this webinar out of your busy schedule. So stay safe. Thank you. Cheers.